yesterday we talked about adding and subtracting a little. So with adding and subtracting complex numbers, you put the real parts together and the imaginary parts together. So 7 plus 5 is 12. 3 minus 4 is negative 1i. So this, when I add these two complex numbers, the result is 12 minus I. Okay, now this one is subtraction. So with subtraction, we never change the signs of the complex number in front of the subtraction. But what we did yesterday was we changed the subtraction to addition, and we change all of the signs in the complex number that follows. So everything behind the subtraction we change to the opposite. And then we put our real parts together, and we put our imaginary parts together. So the difference in these two complex numbers is 2 plus 7i. So the same thing happens here. And you can just change it right here in the problem. You can change it to addition, and then all the signs in the following complex number change. Nothing in front, just behind. So we add our real number parts, and we get negative 2. We add the imaginary parts, and we get negative 3i. So the difference in these two complex numbers is negative 2 minus 3i. Yes, sir?
Like if the subtraction sign was in the front, would it only change the first parentheses?
You're right. So if we had like a negative here, and we had 1 minus 4i plus 2i, this is only going to change what's immediately following it. Okay, so that would become negative 1 plus 4i plus 2i, which would result in negative 1 plus 6i. So only what immediately follows. So here, this is just a sum, so we just add the real parts, add the imaginary parts. Now this is a difference. So everything that follows the subtraction, we change to adding the opposite. So we get negative 2 minus 11i when we put our real parts together and our imaginary parts together. Now this is a sum. When we put the real parts together, they go away. They're opposites. And when I add opposites, that sum is 0. So we don't have to write the 0 for the real part. Then we put our imaginaries together. Negative 1 plus another negative 1 is negative 2i. So that sum is just negative 2i. Okay, I didn't do one like this, but what if you had like 4i minus 3 minus 2i plus 5 minus I? Okay? All right, so try that one either on the back or at the top. So here's a more challenging, you try.
When is your quiz in here? Thursday.
Your quiz in here is Thursday. You do. I changed just that middle one to adding the opposite.
Do you need the answers?
Do you want to do?
Is that over everything we've learned so far?
Yeah, I know.
This will be.
How does that sound?
Some operations with complex Okay, let's take a look at this one. So I'm just going to copy down that first one again. And then I'm going to go through and change my signs where I need to. Okay, so all I did was copy the original problem. Now I see a subtraction. When I see a subtraction, I change it to addition and I change the signs of the complex number that follows. And now I've got all addition. So once I get all addition, I just add the real parts. -3 and +5 is +2. And then 4i and 2i and -i. So 4 plus 2 is 6, minus 1 is 5. And so the result is the complex number 2 plus 5i. Yes, sir?
Why wouldn't it be -2?
Because this is our first real number, which is -3, and then we add to that 5. So the larger number was positive, so it's +2. Okay, so while we've got it on the back, let's refresh ourselves on yesterday real quick. Now remember, yesterday we started simplifying radicals, and then we simplified radicals that had negative numbers in it. So if we had, say, 18, now this one will not be imaginary, will it? Because it's positive. If it's positive, it will not be imaginary. So these are the numbers where you have to think of the largest perfect square that divides into it. So these are the numbers. 4 doesn't go in. 9 does. Okay, so we would break up 18 into 9 times 2. And now remember, we can take the square root of 9. The square root of 9 is 3. We don't know the square root of 2. So this simplifies to 3 roots of 2. Okay, so then we looked at all of these. So what if I had the square root of 125? If you had $1.25 in quarters, how many quarters is that? 5. So 125 breaks up into 25 times 5. And what is the square root of 25? 5. So this would simplify to 5 roots of 5. Now, what would happen if I went back up here and made this one negative and this one negative? It would have what? An I in here. Because we would have the -1. We would have to extend this and do times the -1. So we would bring the I out. The imaginary unit. Yes, sir?
Would it be like, let's say, square root of 17, something you can't solve?
Okay, so if we just had square root of 17, there's absolutely nothing we can do. But if we had square root of -17,
17i.
that would be the square root of 17 times I. And we usually put the imaginary part in front of the radical. See how we stuck I in front of the radical?
Yeah.
In front of the radical? So that's the only thing we could do with that. Yes, Christopher?
Isn't I squared, is it +1 or negative?
-1. Okay? So, before we jump back and talk about multiplying, let's talk about that again. Remember, we said yesterday that I to the first is the square root of -1, and we just write I. But I squared is where we square this, and that gives us negative 1, because when we square a square root, they cancel. So I squared is negative 1. And then I cubed is negative I. And I to the 4th is 1. And what was our silly little thing we said yesterday to help us remember the pattern? I won, I won. I won. I won. And the 2 in the middle are negative. So I won. I won. And the 2 in the middle are negative. Okay, so now let's go back to what we're adding on today, which is multiplication. And then we're going to look at some powers. Oh, hold on. There it is. There it is. Okay, so multiplying with imaginary and complex are just like multiplying with variables. You distribute. So on number 1, we just have this imaginary number times this complex, and we're going to distribute that through there. Okay? So 2i times 3. The 2 times 3 makes 6i. And then 2i times a negative 4i. That's going to be negative 8.
Wouldn't it be I is squared?
It
So
will
it's
be
negative
I
eight
squared.
positive eight?
Okay? You are right. So because we talked about just a second ago that I squared is the same as negative 1. Whenever you see an I squared, it's like multiplying by negative 1. And what does multiplying by negative 1 do to a sign?
Change it.
It just changes it. So what we can do when we see an I squared is just change the sign in front of that number. So that was a minus 8 or a negative 8, so we turn it into a positive. Now, we're so close to being right, but am I in the correct standard form?
No.
No. The real part has to come first and the imaginary part second. So my correct answer would be 8 plus 6i.
So if it were cubed, you would keep it as negative 8.
If it were cubed, we're going to do some cubes in a second. Somewhere. Here we go. And we'll talk about that right there. Yes, ma'am.
If it's just 8i, would it stay negative?
If it were just 8i, we wouldn't change a thing. The only time we have to change is when we get higher powers. Yes, ma'am.
Oh, okay, wait, never mind.
Okay. All right, so let's do this next one. We just have an imaginary that we're going to multiply through this complex. So I times 4 is 4i, and I times 2i is 2i squared. Okay, so the I squared is really like multiplying by negative 1. So it's going to change this positive 2 to a negative 2. So I squared is like multiplying by negative 1, which changes your sign. Yes, ma'am.
So when we have two real numbers, do we add them?
If you did, yes, you would.
Okay.
So now we have this imaginary part, this real part. We got to put it in the right order so that negative 2 is going to come first, and this positive 4i will follow. So the result, the product of this imaginary times this complex is that complex. Yes, sir.
You put 2 in the same
Which one is the same?
number 1 and number 5.
I sure did. They're identical.
It was just
Well, let's just get number 5 then. All right, number 3. We're going to distribute here. So we do negative 3i times the 4 is negative 12i. So negative 3 times the 4, that's where the negative 12 comes from. Now we do negative times a negative, which is a positive 3i squared. But what happens with that I squared? Yeah, it does. It cancels out and changes the sign of that 3 to a negative 3. So the product, the result is negative 3 minus 12i. Okay, I actually want some more room, so I'm gonna start a new page here. Not this one. There. Hopefully that'll do it. Okay, now number 4. It's a complex times a complex. And so it looks just like we have a binomial times a binomial. So we continue to distribute. So first we're going to distribute the real part through the second one. So 1 times 5 is 5. 1 times 2i is 2i. And then next, we distribute the imaginary. So we're taking this positive 3i, and we're going to distribute it through. So 3i times 5 is positive 15. And 3i times 2i, the 3 times 2 makes 6, and the I times I makes I to what power? Very good. So what happens to this I squared? It does, and changes that 6 to a negative 6. Okay, so now all we have left is addition. So we add the real parts together. So the real parts give us 5 and negative 6 is negative 1. And then we add the imaginary parts together. 2 and 15 makes 17i. I'm so sorry. Okay, so we are skipping number 5 because it was a repeat. A whoopsie. Alright, so number 6 is just like number 4. It's a complex times a complex. So once again, we'll distribute. We distribute the 2 through here. And what does that give you? 2
Plus 4i.
plus 4i. Now we distribute the imaginary.
Negative I.
Good.
Plus 2.
Minus. Good. Minus 2i squared, which changes that to a plus 2. Good. Because the I squared is like multiplying by negative 1, it changes that to a plus. Okay, so we'll put real parts together. 2 plus 2 is 4. And imaginary parts together. 4 minus 1 is 3i. Okay, so number 7 looks completely different, but it's actually exactly the same. Because when I square a binomial, it's the same as squaring a complex number. It just means this number times itself. So whenever you see it written as a complex number squared, you just write it out twice and do the exact same thing. Okay? I want you to try to finish number 7. When we distribute the 3 through, we get 3 times 3 is 9, and 3 times 2i is 6i. Then we distribute the 2i through, and we get another 6i, and then we get a positive 4i squared. But what happens with this I squared? It cancels out and changes that to the opposite. So when we add the real parts, 9 plus negative 4 is 5. And then 6i plus 6i is 12i. Okay, number 8. Number 8 has a negative out in front. And I would just leave that negative out in front until the very end. And when you're all done, then you can change all of your signs. So we're going to still distribute. Still distribute. And then once we've done everything we can do, we will go back through and change all of our signs. So this gives me 5 plus 15i minus 2i, and then minus 6i squared. But what does this I squared do?
Cancel out.
It's going to cancel out and change that sign. So this simplifies to 5 plus 6 is 11, and 15 minus 2 is 13i. But because we have this negative out in front, what does it do to both of these signs? Changes them. So my answer is negative 11 minus 13i. Okay, so you try number 9 and number 11 right now. I want you to try 9 and 11. And if you're not sure what to do, I would like you to ask. I'm going to pause the video while we do these. Okay, let's take a look at these. So, number 9, did you remember that when you square it, you just write it out twice and then multiply through, distribute through. So when we distribute the 1, we get 1 minus 5i. When you distribute the negative 5i, you get negative 5i plus 25i squared. Okay, when we do this is going to change this sign. So a negative times a negative made it positive, but the I squared changes it back to negative. And then 1 and a negative 25 is a negative 24, and negative 5 and negative 5 is negative 10i. Okay, number 11, when I distribute here, I get negative 2i minus 8i squared. That multiplying by I squared, whoops, trying to change colors, is going to change this to a positive 8. So this simplifies to 8 minus 2i. Okay, now number 10. is our first one that has a power of I to start with. So that's where we're going back to our little mnemonic. And I would like to see you guys write this at the top of your quiz in this class and in your math class. I want you to write I1, and then 2 in the middle are negative. So I1. So whenever you see a power of I, we're going to simplify it to what that equals. So I to the third is really negative I. So right here, the first thing we're going to do is replace that I to the third with a negative I. Okay, so on the first one, we have to distribute a negative I. And on the second one, all we have to do is change our signs. Yes, ma'am.
For that one, can we just like do the addition or subtraction part first and then contribute the I?
We have to distribute the I first because PEMDAS tells us we have to do multiplication before we do addition and subtraction. So we have to multiply through by this first before we can add and subtract. So we're going to multiply, and that's going to give us negative 2I squared plus 5I. But what does that I squared do? Right here, this negative 2I squared.
Cancels out and becomes positive.
Okay, so that's going to become a positive 2. And then this is minus 3 minus 4I. It's a minus 3 and a minus 4I. So we're going to put the positive 2 together with a negative 3, and that gives us negative 1. And then we're going to put the positive 5I with the negative 4I, and that gives us 1I. So this is our answer. Our answer is right here. Those two things together, the complex answer, negative 1 plus I. Okay, now, powers of I are really cool because they repeat in a pattern. I to the 5th starts over. So we did I, negative 1, negative I, 1. I to the 5th is I again. I to the 6th is negative 1. I to the 7th is negative I to the 8th is 1. It's a pattern that repeats over and over again. And you guys see that it repeats every 4. Let me prove to you why I to the 5th is just I. Could I write I to the 5th as I to the 4th times I to the 1st?
Yeah.
Yeah, because 4 plus 1 is 5. What do we say I to the 4th was? 1. And I to the 1st is just I. So what is 1 times I? I to the 6th is really I to the 4th times I squared. Well, we said I to the 4th was 1. And we said I squared is negative 1. So what is 1 times negative 1? Yeah. Okay? So the pattern does repeat, and we can prove that it works. Now, this one's, this should be just number 12, not number 12, number 15. Sorry about that. So number 12 is I to the 16th. Now we don't want to keep counting up. It would take us forever. Because you might have one on your test that's like I to the 81st. And we can't just write down that pattern forever until we get there. So our shortcut is, because we know it repeats every 4, we can take your exponent and divide it by 4. And what we're looking for is the remainder. And then we're going to look at the remainder. Okay, so I'm going to try one that's not there. I'm going to do like I to the 21st. How many times does 4 go into 21? 5. And how many are left over? What's the remainder? 1. So I to the 21st is really the same as I to the first power, which is just I. Okay, let's do I to the 35th power. Okay, if we were to take and say, all right, how many times does 4 go into 35?
No.
8. Okay, and that's 32, right? So what's our remainder? The remainder is, what is 35 minus 32? 3. So I to the 35th is the same as I to the 3rd. What is I to the 3rd? Negative I. We're going to work on this part again some tomorrow because this is harder. Now, the cool part is, this is if there's a remainder of 1. This is the answer when there's a remainder of 2. This is an answer when there's a remainder of 3. But if we're dividing by 4, there's never a remainder of 4. Because if it divides by 4, the remainder would be 0. So if we have no remainder, then it's like I to the 4th. Okay, so I to the 16th, 16 divides by 4 evenly, doesn't it? There's no remainder. So it's like I to the 4th, which is 1. 22. What's my remainder? 2. So this simplifies to negative 1. Take 12. What's my remainder when I divide by 4? How many times does 4 go into 12? 3. Is there a remainder? No. So you're right. The answer simplifies to 1 because there's no remainder. And 4 times 1 is just, that's the ugliest looking 4 I think I've ever drawn. Sorry. Okay. Now, this problem and this problem look very similar, but they're different. Actually, they're not different at all. This problem and this problem are the exact same problem. It would be different if we put the parentheses right here. That would be different. So these two problems are the exact same. So I squared is the same as negative 1. So this is negative 3 times negative 1, which is 3. So both of these are the same. They're both 3. Okay. Yes, sir?
Number 15.
Yes.
Why would it be 4?
Okay. So when we take I to the 12th, when you have a power that's greater than 4, you have to take that exponent and divide it by 4. Well, when we divide 12 by 4, there's no remainder. So it's the same as no remainder, which is I to the 4th, a remainder of 0. And I to the 4th simplifies to 1. So this is 4 times 1, which is 4. Okay. I'm going to stop recording now, but if you guys have any more questions for me,